Today we are going to discuss about some important topics of chapter vector. One of the most important topics of this chapter is relative velocity. The definition is written in question number 9. Look at the page. The apparent velocity of an object with respect to another object, which may be at rest or in motion, is called relative velocity. For example, the earth is revolving the sun with velocity u, then the relative velocity of the sun will be minus u, but practically sun has no motion. There are different types of relative velocity. Object moves along the same direction. For this case, the relative velocity is taken into account like this: w is equal to v minus u. That means you have to subtract the two velocities. Number 2, object moves in opposite direction. For this case, the relative velocity w will be v minus u is equal to v plus u. Another way, w is equal to minus u minus v is equal to minus of v plus u. So it is clear from the above discussion that when the two objects moves along the same direction, the velocity should be subtracted, and when the objects are in opposite direction, the velocity will be added, and that will be the relative velocity. But if one of the object makes an angle with another object and is in motion, then what will be the relative velocity? The given figure shows the relative velocity for this case. U is the velocity of an object, v is the velocity of another object. Then the relative velocity will be w is equal to root over of u square plus v square minus 2uv cos alpha. If u and v makes angle 90 degree, then the relative velocity w will be root over of u square plus v square. Another topics concerning the relative velocity is shown in question number 10. Relative velocity of rain with respect to a person who is in motion. Suppose u is the velocity of the man and v is the velocity of the rain. It is clear from the figure that u and v makes angle 90 degree. Therefore, the relative velocity will be w is equal to root over of u square plus v square. And the direction of the relative velocity tan theta is equal to u by v. Therefore, theta is equal to tan inverse u by v. Another topics of vector is product. Actually, there are two kinds of vectors: product, dot product and cross product. Look at the figure for the dot product. When the vector A shifts to vector B, making some angle theta, then it can be shown like A dot V. The dot product formula A dot V is equal to modulus of A into modulus of B into cos theta. If B vector shifts to A vector, Then b vector dot a vector will be mod of b mod of a cos of minus theta. Here angle is taken clockwise, that's why it is taken minus theta. Therefore we can write down a vector into b vector cos theta. Equation number 2. From equation number 1 and 2 it is clear that a vector dot b vector means b vector dot a vectors. There are some characteristics of dot product which is shown below. I cap dot I cap, what will be the result? I cap dot I cap is equal to mod of I cap into cos theta. Here theta will be 0 because two similar unit vectors makes angle 0 degree. Therefore I dot I is equal to 1 into 1 into 1 is equal to 1. Similarly, the dot product of two like unit vector j cap dot j cap is equal to 1 and k cap dot k cap is equal to 1. But if we take the dot product of two different unit vectors, the result will be 0. That is I cap vector dot j cap vector is equal to 0. Why? Because I and j makes angle 90 degree. Therefore mod of I mod of j cos 90 is equal to 0. Similarly j vector k vector is equal to 0. I cap dot k cap also 0.